Hello friends, good morning and welcome to a new session of 3 hinged arches. In previous session, we have seen or solved two numericals on 3 hinged arches in which we have learned how to evaluate reactions, that is vertical as well as horizontal reactions for a 3 hinged arch, as well as we have seen how to determine bending moment of an arch and how to locate maximum point of location for bending moment. Okay, so today we shall continue with next type of problems, determining normal thrust and radial shear in an arch. Okay, so this is a given arch whose span is 60 meter. There are 2 point loads. Each point load is at 15 meter from the support. One is 20 kilonewton, another is 30 kilonewton. Central rise for this arch is 15 meter. Okay, and we have to find normal thrust and radial shear at 20 meter from support A. So somewhere here. Okay, so procedure is same. That is, we will first of all consider the given arch as simply supported beam. We will show the external loading as it is on the beam, and then we shall first find vertical reactions. Okay, so here is our simply supported beam for the given arch with these two external loadings. Okay, so this distance is 15. This is also 15. So the remaining distance between these two is 30 meters. So if you get or apply summation fx is equal to 0, we are going to get ha is equal to hb. And we have to find va and vb. So this is what now we are doing. Summation fy is equal to 0. This will give us va plus vb as 20 plus 30, correct? So this is 50 kilonewton. Next, summation of movement about any support. I will take A. So this will give us one equation with unknown as vb. So minus vb into 60 plus 30 into 45 plus 20 into 15 is equal to 0. From this we will get vertical reaction on support B. So let us calculate. So it is 30 into 45 plus 20 into 15 upon 60. So answer is 27.5 kilonewton. Okay. So find out VA. 50 minus 27.5. How much? 22.5. 22.5 kilonewton. Now we have to find HB. So again we will consider any part of the arch, either A to C or B to C, anything. Previous cases we have seen BC part, now we will consider AC part. Anything you can consider. So here is C, 20 kilonewton is on, 15 meter from A. So this is HA. Okay, this is VA. VA is how much? 22.5 kilonewton. So how much is this distance? 30 meters, correct? Half. And how much is vertical? Central rise is also given, 15 meter. So from this we are going to get horizontal reaction. So take summation of moment about C. that is moment at crown. So 22.5 into 30 minus HA into 15 and moment due to 20. So minus 20 into 30 minus, this is 15. So 30 minus 15 is 15. Okay. So from this we will get HA as how much? See, 22.5 into 30 minus 20 into 15 upon 15. So 25 kilonewton is horizontal reaction. So up to this everything is same as per previous problems on arches. So I'll just note down these values here. VB is how much? 27.5. HB is 25. So is HA. Okay. Now I will rub this all because we have to find now normal thrust and radial shear. So in previous session we have seen the concept of normal thrust and radial shear and how to find out these two values. Okay. So for this we need shear force at a given section. We have to find normal thrust and radial shear at 20 meter. So at 20 meter from A we need to find how much is net shear force. Okay. So what is net shear force? Basic definition from Sohm theory. Summation of net force which is unbalanced on any side of the section. Okay. Unbalanced force on any side of the section is shear force. So we will consider left hand side of the arch. Okay. So let us draw it here. So this is 25 horizontally. Then VA 22.5. Okay. Then this 20. So what is unbalanced force on left hand side? Summation Fy is equal to 0. If you apply, what you will get is V. Let us say this is point D. Okay. So VD is equal to 22.5 minus 20. So 22.5 minus 20 is 2.5 kilonewton. How much is HD? So this is VD. HD is equal to 25 kilonewton. So we need these two values. Correct. One more value we require, that is theta. So what is theta? In fact, tan theta is equal to dy by dx. We have seen this dy by dx in the first session of three hinged arches. If you recall, equation is 4yc upon L square into L minus 2x. Y is 4yc upon L square, x into L minus x square. Okay, L minus x. But dy by dx is 4yc upon L square into L minus 2x. Correct? So this is equation for tan theta. So can we get tan theta on point D? So 4 times 15 upon span 60. So 60 square into 60 minus 2 times, what is x? X is distance of point D from support A, 20 meters. So find out this value now. So 60 minus 2 times 20 is 40. 60 minus 40 is 20. So 4 into 15 into 20 upon 60 square. Okay. So it is 0.33. So how much is theta? Tan inverse of 0.33. See how much is the angle? It is 18.44. Okay. 18.44 degree or 43 degree, whatever. So these three values we need for normal thrust. So let us calculate normal thrust. So what is equation for normal thrust? HD cos theta plus VD sin theta, if you remember. So what is HD? 25 into cos of 18.44 plus what is VD? VD is 2.5 net shear force on point D into sine of 18.44. Okay. So calculate this value, that will give us normal thrust. So 25 cos of 18.43 or 44 plus 2.5 sine of 18.44. So the value is 24.51. 24.51 kilonewton. Another component, radial shear. Radial shear is HD sin theta minus VD cos theta. Okay. So HD is 25 into sine of 18.44 minus VD is 2.5 cos of 18.44. Calculate this value. So this is 5.54 kilonewton. Okay. So that is the procedure to evaluate these two terms, normal thrust and radial shear. This is simple. Even if we know the total procedure now, where are the chances of mistakes? Here. By mistake we take VA or VB value for VD. But please remember, in both the equations, VD is net shear force at the section where you have been asked to calculate these two terms. Please remember, this is net shear force and not vertical reaction of the arch. Okay. Thank you, friends. If you are new to this channel, please subscribe. If you like the videos, do comment. If you have any questions, do ask them in the comment. Thank you. Now we have another problem with one variety, that is there are 2 point loads just like previous case, but they are now inclined with, they are having inclination of 45 and 30 respectively with respect to horizontal. Okay, so this span is 12 meter, central rise is 3 meter, and we have to find normal thrust and radial shear at the crown point C. Okay, so let us start. So again we are going to consider this given arch as simply supported beam. Now we will convert or replace this inclined force with two components of each force. So when we are finding vertical forces, only vertical components will come into picture. So on beam we will show only its vertical components, 40 sine 45. Okay, so 40 sine 45 is how much? 28.28 kilonewton. Okay, and here 30 sine 30 is 15 kilonewton. So we shall first of all find these two vertical reactions. Okay, and horizontal components are 40 cos 45, so it is 28.28 again, and 30 cos 15 is 28.98. Okay, so summation Fy, so VA plus VB is equal to 28.28 plus 15, so it is 43.28 kilonewton. Then summation of movement about A is equal to 0. It is going to give us this equation, minus VB into 12 plus 15 into 12 minus 2.5, so it is 9.5, plus 28.28 into 2 is equal to 0. So how much is VB from this? Let us calculate. 15 into 9.5 plus 28.28 into 2 upon 12. So it is 16.59 kilonewton. So VA will be how much? 43.28 minus 16.59. So it is 26.69 kilonewton. Okay, 26.69 kilonewton. Now we have to calculate HA and HB. It is not like previous numericals where HA used to be equal to HB. Why? Because there are two inclined forces at different angles, different magnitudes of forces. So there is definitely an unbalanced horizontal force. Okay. So for the complete arch, now we shall apply summation Fx is equal to 0. Okay. So what are we going to get? HA minus HB. Okay. It is equal to 28.28, which is horizontal component of 40. So it is 40 cos 45, and this is 25.98, which is horizontal component of 30. 30 cos 30. So minus 25.98. Okay. We'll take all these on one side of the equation. So net summation of these forces is equal to 0. Okay. So HA minus HB is equal to 25.98. I think this is plus. So 25.98 minus 28.28. So it is minus 2.3. Okay. And now we have to find HA and HB. So again we will consider free body diagram of A to C. Okay. Here somewhere at 2 meter is these two forces. Now there are two components. 28.28. I will show like this. 28.28, which is vertical component. Horizontal component is here. Again same 28.28. On C there is nothing. On A, vertical reaction VA, how much? 26.69. And then HA, I will show here, which is unknown, that we have to find. Okay. So here summation of movement about C is equal to 0, about the crown. So 26.69 into how much is this distance? A to C horizontal distance. A to C 6. Okay. 26.69 into 6 minus HA into vertical distance between A and C 3. Then Now carefully see. This total is 3. From this we have to subtract this. So we need y ordinate for this. Okay. And this 28.28 into this horizontal distance. So we will write now here minus 28.28. This is for vertical component. 28.28 into 4. And both are anti-clockwise movements, so minus. Okay. Now for horizontal, 28.28 into 3 minus y. It is equal to 0. I hope you have understood this equation. Our y value is from here to here. Okay. This we will find using this our derivation of first session for 3 hinged arches. 4yc upon L square x into L minus x. It is equal to, substitute the values one by one. 4 into yc is how much? 3 upon L is 12 meters, so 12 square into x. X is how much? We want this y ordinate, correct? Below this 28.28. So this x is 2 into 12 minus 2. Okay. So find out this y value. 4 into 3 into 2 into 12 minus 2 is 10 upon 12 square. So it is 1.67 meters. Okay. So this is 1.67. Now I will rub this. We need to remember these values. So I'll note down here. VB 16.59. This one VA 26.69 kilonewton. Okay. So we want movement about C. So HA we will get from this. So 26.69 into 6. I'll write directly. $160.14. Okay. Minus 3HA. Then 28.28 into 4 is 113.12. And here 28.28 into total 3. From that we have to subtract 1.67. So it is 37.61. It is equal to 0. So from this we are going to get HA. See now. 160.14 minus 113.12 minus 37.61 divided by this 3. So it is 3.14. HA is 3.14 kilonewton. So how much will be HB? Substitute HA as 3.14. You bring it on right hand side. So this will be minus 2.3 minus 3.14. Okay. Correct? So this will be 0.84. No, not 0.84. Actually, we have to add these two. Minus 2.3 minus 3.14. Correct? With minus sign. So minus sign from both the ends gets cancelled. Minus HB and minus 5.44. So this answer is 5.44 kilonewton. Our calculated values of HA and HB are positive. It means our assumed directions of HA and HB are correct. HA we have assumed towards right 3.14 and HB we have assumed towards left. Okay. So how much is HB? 5.44. Now we will be able to find out normal thrust and radial shear. Okay, so we will find out what is net shear force from this free body diagram itself. Now I will rub some unwanted matter so that we will be clear. Okay, all values are with us here, so I will rub this one also. So net shear force on C vertically, so we will say VC. How much is VC? 26.69 upward, so positive, minus 28.28, correct? That's it, only two. So how much is net shear force? Let us calculate. 26.69 minus 28.28, so value is minus 1.59 kilonewton. Okay, so keep it as minus. We will keep net shear force value as minus in the equation of normal thrust as well as radial shear. Okay, now HC. What is HC? Net horizontal force. So HA is how much? 3.14. It is on right hand side, so positive. Another is 28.28. Okay, so 3.14 plus 28.28, it is 31.42 kilonewton. So normal thrust is, instead of HD we shall say HC. HC cos theta plus VC sin theta. Okay, so substitute the values. How much is HC? 31.42. One more thing is remaining, theta, that we shall calculate first. So tan theta, okay, tan theta is equal to dy by dx. It is equal to, what is the equation? 4yc upon L square into L minus 2x. Okay, so tan theta is equal to 4 into 3 upon 12 square into L is 12 minus, how much is x? X means location or distance from support A, where we have to find normal thrust, radial shear, where at C. So how much is distance of C from A? 6 into 2. Okay, so 12 minus 12 is 0, so tan theta 0, correct? Tan theta is 0, it means how much is theta? 0, correct? So theta is 0. If tan theta is 0, because 12 minus 12, I hope this is correct. Yes. So 31 point, H is 3.14, cos 0 is 1, plus sin 0 is 0. So that is normal thrust over radial shear. HC sin theta minus VC cos theta, correct? So again first term will be 0 because sin 0 is 0. So minus VC is how much? Minus 1.59 into cos 0 is again 1, correct? So minus minus plus 1.59 kilonewton over. A little bit complicated because there were inclined loads, chances of mistakes were here, then obviously here finding out net shear force, then tan theta. Okay, again here one more thing, VC we have got minus. So what about the equation? Simple, keep our equation same. If your H is minus, not in this case, but if your H value is minus, keep minus here. And as VC was minus here, we have kept VC minus without changing our equation, without disturbing the equation. Okay, let me know what are your comments regarding this problem. If you felt this was easy, do comment in the section. Thank you.